Yeah, how many people use Azure Kubernetes Services here before? Really? Are you? You have been used for a while. Okay. Yeah, thanks for coming for this talk. And I'm Jorge Arteiro, Cloud Developer Advocate for Microsoft. And yeah, I'm one of the guys that started doing containers where nobody believed it in 2015, 14. And now 2022, I became that cloud native in containers, cloud developer advocate for Microsoft. And there are some of those guys at the room as well. And let's talk about, like the basics of containers and Kubernetes. There is another talk, 140. Then, even I had to restart everything, but hopefully everything will be starting back. If we cannot, have time for demos, we can do on the afternoon session. And I also go on the Azure Container Apps on the other session. If you are interested to like a serverless Kubernetes platform. But now we're going to talk about Azure Kubernetes Service. And just for you to know, that's my channel, that's my community. I created 2 years ago during COVID, where I help people to create content, write blogs, record videos. If you are not like a native English speaker like myself, I like to help people to break that, big wall that's in front of you to speak here, and also to write, sometimes even to write in English when you move to another country. I'm here for 16 years. I'm never going to change my accent, then that's what I do, and you are always welcome to join. And there are 1,400 subscribers, I don't know why, but like 25 or more speakers that produce like 103 videos in 2 years. I think that's amazing for, during COVID, in 2 years we do all these things. And let's talk about, the first thing, why Kubernetes? And the first thing came to my mind was, Cloud Native Compute Foundation. If you don't know what it is, it's a foundation that was created inside Linux Foundation to accommodate what we call Cloud Native, and that's the definition on the website. It's all about, people say, is Cloud Native containers? Not just containers, there's a few things there that, I would say it's more like immutable infrastructure than containers, if you can do that in another way. There are people doing that in VMs as well, but not the same way that containers is doing. People using Packer for many years, or the things to create, like automate the process of build like a VM template. How many people are doing that for, maybe have done that before for many years using Packer, HashiCorp products. And all these things, immutable, multi-cloud, private cloud, hybrid cloud, that's what we call now, hybrid cloud, would be on-premise, your private cloud, or public clouds. When you mix that in development with microservice, immutable containers, you create that, what I call cloud native environment. And loose couple is a big one there as well. And the way that we manage dependency is all, what cloud native does. I'm going to give you some examples from, old products compared with AKS. I think that's one question everyone asks me. Why should I be using AKS? Should not be using, I'm using Azure Service for many, many years. I'm using other solutions. Why I should move to AKS? You don't have to move, but you're going to see the options that you have. And as you can see, Kubernetes is just one of the projects of CNCF. I would say the main project. Many of them wouldn't be there if it wasn't for Kubernetes itself. And Microsoft is proud to say that they have Helm, was a product created by a company, was acquired by Microsoft called Days. And Helm is what you call the package management for Kubernetes. If you have the package manager for Linux, that's the package manager for Kubernetes, one of them. But and big names are Envoy Proxy, etcd for storage there, Containerd that manage the whole, container runtimes and image. I have some slides there that I can show as well, but I'm trying to talk here for developers, okay, not for the infra. Probably you guys don't care much about managing the infrastructure. You care manage about your application. Who is a developer here? Most of the crowd is a developer, yeah. And that's the main talk. But you can see a few projects here that Microsoft work, like DEPA, CADA for scaling. There are very nice projects like Flux, Argo CD for GitOps. Is anyone doing GitOps here? Who doesn't know what GitOps is? GitOps. Okay, everybody knows what GitOps is? Anyone use Flux or Argo CD? Which one? Argo. Okay, nice. See, that's nice. There's a lot of things for us to learn here, but the first thing I say for developers is look on those projects. They're all open source. You can learn a lot from that. If you want to do cloud native, just look in the source code of these projects, you can learn something. Most of them are in Go, but you still can learn how they're using GRPC. We had a talk yesterday about GRPC. APIs, not using REST API, using gRPC. And most of those products, they use gRPC. And I would say like the biggest library now is like CNCF for Cloud Native because all the source code pretty much is open. You can go there and have a look. Many of those products that are SDK for the language, then you can see how they use the product, how they build the SDK, and how they consume those products. And there's another one that works, another one is Brigades. It's like a async framework for Kubernetes. And there are big projects here, coming. And that's how CNCF works. It's like an incubation for Kubernetes. And Azure Kubernetes Services is a big part of that. And we have on this diagram here what we call cloud native on Azure. And the platforms there, you have Azure Kubernetes Service, OpenShift from Red Hat, Azure Container Apps now, that's built on top of Kubernetes. And not just on Kubernetes, it's built on top of Azure Kubernetes Service. Okay, you have a platform built on top of Azure Kubernetes Service now. That's fully managed by Microsoft, and you just deploy your application. That's more the afternoon talk. You have Azure Functions, if you want to say that's serverless, like how could be cloud native, depends how you build the Azure Functions. And I would say there are more. There are Spring Cloud as well for Java. That's also built on top of container orchestrators and mostly Kubernetes as well. That's not even here on the diagram. And from the community on the left side there, you can see CADA, DEPA, Kubernetes, and other projects there. And that's how we are on the space and how AKS comes in place. I love this slide because I did this slide. If someone saw my talks, probably remember this many years ago. And I said I want to bring this slide back because that's exactly what just happened last month. I used to have like a question mark on the ARM side. And I used to have preview on the Windows one. Now we can have a cluster where we can deploy multi-platform. Azure Kubernetes Service, even from the Azure portal, you can create a cluster and say, I want a Windows node pool, I want a Linux node pool, and I want an ARM node pool. Now it's in preview. I'm not sure if it's on the portal, but it's available. And you can create this. When you say AKS is a cluster, we still can see the VMs, the virtual machines. But imagine if you put all those VMs together and you look all the CPU and memory that you have available is like a big VM. We don't care where the application is running. That's exactly what Kubernetes does. Kubernetes go and say, okay, I'm going to put your application here, here, here. You don't care about where the physical node where the application is running. And if you try to use Kubernetes maybe 2 or 3 years ago, now it's completely different because now we have those enterprise features that you don't have to manage the cluster too much. Okay, I know that's in production. They have customers here that say, it's pretty hard to keep moving because Kubernetes moves very fast. They say, I was a new version. And you have to make sure that everything is going to work, it's not going to break anything, you have to look for what changed on the platform, if everything is going to work. But all the process to update the cluster, there's a lot of automation there, there's pretty much done. You can even say how you want to do it. Every time there is a minor version, I want to do the upgrade. I want to schedule that upgrade for like a weekend, for at night. You can define that. You can customize even your Linux VM there. Say, no, I don't want the standard VM, the image that you create there for the cluster for some reason, like an enterprise company normally ask for that. You can do that if you want on regulated markets and everything. But it's all based in configurations, so you don't have to understand really the whole Kubernetes to do that. That's simplified for the user. Then you as a developer have to care about that. No, that's a nice thing. To create like a developer cluster, you're going to see that you can create a cluster yourself. Now we have a recommendation. You can pick the type of cluster, development, production, test. And there is outscaling for that. You don't have to have all these VMs sitting there waiting for the load. No, you say I want a cluster with 1 node, scaling to 5. That's my development cluster. That's what I have here. And then there's just 1 node running. Then I can set something to stop those VMs, stop the whole cluster. What I want, I can stop per node pool, or I can stop the whole cluster, everything. Then I don't pay. Probably going to pay just for the storage that's sitting there, but we're not paying for the VM running. Means there is ways to manage cost. People say, that's not serverless, I'm keeping paying. It's not like that. There's outscaling on those VMs, and you don't have to pay. And now with ARM, you probably can have a development cluster very cheap using ARM. Okay. Just before I finish, and in production, if you want to, similar like Azure Functions are, you can, burst your scaling outside the cluster. You can use something called virtual kubelet, or using Azure Container Instance. That's another product. That's complete serverless. Azure Container Instance, let's compare, let's say, with Azure Functions. That's serverless. Means that you just pay when it's running. And there's a way to install that virtual node or virtual kubelet in your AKS and tell them, for these workloads here, that's going to scale a lot. I don't want to rely on the node pools. I want to scaling outside the cluster using Azure Container Instance. Then I just pay, like a serverless thing. And there's another way to mix what's not like fully serverless with what's serverless. And that's how ACI works. And just because developers always like to understand how things works. I'm a developer. I like to understand it. I want to know where my application is running. You show me a bunch of VMs there, and if I even go back here, you can see there is a control plane there that you don't touch. That's Microsoft managed, fully managed by Microsoft. You don't even pay for that. You only pay if you want SLA. You don't need SLA in development. In production, you can pay. But we're giving, any Kubernetes cluster, you need a control plane. But that control plane, you don't have to care. You only care about, where your application is running. And if you want to extend that, going for virtual kubelet, how Kubernetes works. On each node, like each VM, when we create the cluster, there's something running there called kubelet. That's why all the communication, I'm not going into details how that works, but that's how all the communication works. And there's another thing called scheduler that's going to, checking the things where they're going to run, if they have like 5 or 10 VMs. And what Virtual Kubelet does, they just create like a fake kubelet inside the cluster and tell that every time that the scheduler tries to schedule something here, just go and send to outside the cluster. Then there is an integration with Azure, and Virtual Kubelet, even there are integration with other things. You can even run in other clouds, in other products. Okay, not just Azure Container Instance. Many people never use that. I think it's a hidden feature there on AKS. And I recommend you to have a look, because it could be the solution that you're looking for. If you wanna, in some case, like once a month, you're going to run something that you need like huge scaling to process all these things, maybe ACI is a perfect solution. Even if your cluster can scale up and down the nodes, but maybe you don't need that. Maybe you can just using ACI. It's very cheap as well. And that's the architecture of that we just talked about. See the nodes here on the right with the kubelet and the scheduler and etcd. That's what the Kubernetes use. And Kubernetes API means that you as a developer are going to talk with API and ask AKS to do things. Okay, that's how Kubernetes works. Everything is an API. And when you create a cluster, you connect with that API and use like a command line tool. Who likes command line tools? CLI tool again. And that's kubectl, that we normally talk. But why I say that? Because in development, you need to use that, okay? Or use like a VS Code extension, or Visual Studio extension, or anything that you like to talk with that cluster. I'd say like 5 years ago, 3 to 5 years ago, I used to need more, the kubectl. Now we have so many different options. You have Visual Studio Code extension, have Rancher Desktop. I have Rancher Desktop running here. They even give you that all for free. You have a dashboard. If you haven't seen there, you right-click, there is a dashboard, and you can see the whole cluster. And you can do your local development even without AKS. You can do like simulate the whole thing locally in a Kubernetes cluster the same way, that you're going to do in production. You're going to do on AKS. Or you can create an AKS cluster as a developer cluster, and you can talk with this cluster directly as well. And your VS Code extension is going to be able to connect there and see the whole thing. To understand more, like Kubernetes is, you as a developer, you don't have to understand, the whole infrastructure. Leave that for who is going to deploy. And I think one of the mistakes I saw in the last, 7 years with Kubernetes is the developers, they tried first to understand how that works, how the cluster works, more the infrastructure side than the development side. Okay, I'm not saying that you don't have to understand that, but don't do that at the first. Leave that for later. Once you figure out the whole thing, the whole development side, then you can go and try to understand, okay, now I'm going to do the hard way and see how that cluster works, where my application is running. But here just say, all those VMs that I was talking about there, they're all connected in a network. And every time that you deploy application, for example, there's one option that you can have IP number, for example, on your Azure Virtual Network. You deploy application, you can have IPs. You can simulate a virtual network inside your cluster as well. Means that there's many different ways to do networking, to do policy, security. I don't think that's the first thing the developer should be looking into, is all that. We are simplifying that, automating that. There is even ways now to enforce. We're going to enforce, Azure policies on your cluster. But the developer, they don't have to care that. If the cluster was created the right way, with the right policies, with the right configuration, the developer, they skip that, okay? But what the developer need to know, that your application is running inside the virtual network. Imagine you create a VM and you put your application there. IaaS, and you deploy application. But that virtual machine, there is IP number, you can, direct traffic there. It's the same thing in the cluster. When you do a simple deployment from Visual Studio, when you ask Kubernetes to deploy application, that's it. That's going to happen, like the connection with virtual network, you're going to get IP, you can connect disks as well, volumes, we call volumes in Kubernetes. Means you can have Azure files connected there. So you have files now on App Service as well. Have GRPC on App Service. I mean, the other products are also incorporating all those, features on the other products as well. Means that you don't have to move. But you have to understand that maybe the infrastructure team of your company are going to decide to use Kubernetes for many other reasons. That the developers sometimes say, why are you going to use Kubernetes if we can do something else? But there are other reasons. And, things called open service mesh or service mesh, where they're going to enforce policies. Then keep in mind, maybe it's something that you have to do it because your company is using, or means that you have to be prepared for that. If you're not using that, you have to give a go. That's my opinion. And it's not going to be, everything now is going to be containers and Kubernetes. No, it will be a mix. You're going to use static apps for maybe your front end, maybe you're going to use the AKS or container apps for your microservice. That's how I see that, that play in the future. You have Azure functions as well, and then that's how Kubernetes works. They allow that connection with load balancing, okay? Then network there, how that works. I want to deploy my application. I just say I want to expose my application on port 443, and I want like a load balancer for that. They're going to provision a load balancer, Azure load balancer, to send the traffic for your application. And Kubernetes inside, they know where your application is running. There's one thing called service, where they just get the external traffic and they send for that. If it's a microservice just running inside your VNet, you don't want to expose externally, you can do an internal load balancer as well. Yesterday someone was talking about client load balancing. Cloud load balancing is when the microserver himself knows where the others are. Okay, and if someone was on the GRPC talk yesterday, that's what client load balancing is. And I used to do client load balancing 20 years ago. Okay, 20 years ago, there's libraries to do exactly what GRPC is doing. And there are companies using, the company I worked 20 years ago is still using that. The library for .NET for 20 years. Since .NET 2, I think. And that's exactly what they're doing. And Kubernetes is using. Even if you watch James from Microsoft talking about GRPC on his video, exactly comparing with Kubernetes. Because the client load balancer that they implemented on ESP.NET Core for GRPC is exactly what Kubernetes does. What Kubernetes does. Imagine that each share here is one node of your cluster. I put in I need 3 copies of my application. I put one here, another here, another here. And there is this guy here that's doing the load balancing. Okay, your application is there, there, and there. And they just do the internal load balancing using gRPC, all that communication there, and they send the traffic there. And that's how the thing works. If you go back, that's how it is like as well. Let's see, okay, to go fast. That's how it used to be containers. We have Docker create, this library, this daemon called Docker-D, where from a command line, you could use container-D, that's a CNCF project. That pretty much is a high-level library, let's say, that's going to talk with containers runtime, that's going to create the container. And on Linux, there is this guy called runc, that's the main guy that creates the container. Now I'm going to details how containers works on Linux, on Windows, but high level, that's how it works. The kernel is there, and runc goes and makes sure that they isolate a container on the kernel level. And Kubernetes is on top of this. You're going to see on the next slide. Let's go skip that one. I think I have, no, sorry. I don't think that's here. Yeah, that's a Linux container. The Windows containers is the same thing, but we have two flavors. We have what they call Windows container, Windows Server container, and Hyper-V container. Hyper-V creates another layer of isolation for your container. Okay, then if you're doing Windows containers, the only way I think would be more using Docker Desktop. You can switch to Windows containers. And if you're using .NET Framework, the full .NET Framework, you still can use containers. You can create like the node pool with Windows on AKS. There's a lot of documentation. There are, Vinicius Apolinario, that's like the cloud developer advocate for Windows containers. Vinicius is preparing a lot of documentation, updating documentation to explain how that works. There's a lot of investment on that as well. And if you're looking to migrate something that's legacy, that will be available on AKS. If it makes sense for you. If not, you can use VMs, but there is an option to migrate legacy for AKS using full .NET Framework. Windows Server 2022 is available in preview on AKS as well. You can have Windows Server 2022 images, and you can create this. Hyper-V containers is coming as well. It's not there yet, only the normal containers, but Hyper-V is coming. And there's another one that many people never use called Linux containers on Windows. You could create like a Linux containers on your Windows host, but was never really went in production, fully production, but something that many people used before. And nice thing of that Linux container Windows is, imagine now I could have only Windows nodes and I could mix Linux and Windows. It's similar to like WSL is doing, Windows Subsystem for Linux, running like Linux on Windows. And that's my old slide that I used to show that. How the life cycle of for a developer is even showing Windows there. But look for your Git at the left there. You get your Git, get your source code, and you have to, what you call create a Docker image. You have to build that. Because if you don't understand this life cycle, you're never going to get on the Kubernetes path, in my opinion. And then you build the image. There is Azure Container Registry there, the private container registry, where you can build inside the registry. Means that you don't have to even have Docker in your machine. They can build there on the Azure Container Registry, ACR. And then use Helm or kubectl or whatever integration or pipeline, GitHub Actions to send that to Kubernetes. Docker, if you want to use locally, you can use Docker Compose now as well. Like we just released for Azure Container Apps, Docker Compose extension. If you haven't seen, it was last week. And you can get a Docker Compose file that's saying, a composition of application, not just one, like front end. You could deploy front end, back end, all together. That's called Docker Compose if you never use. But before I show here my computer, that's how a Dockerfile works. Let's go here for you to get your application, you put inside a container to deploy on app service, AKS, or any service like as a container. You need to write this file called Dockerfile. And you have to start for .NET, I'm going to talk more about .NET here, let's say .NET 6. I'm starting from that image. It's a Linux image from Microsoft, ESP.NET 6. I call this base, okay? Then I'm defining my work directory. I'm exposing the ports I'm going to work for port 80 and 443. And now I have this base image there in purple. Then, now I define another one, because now I need to build my application. Okay, the first one was just the base where I'm going to deploy my application. Okay, I'm creating like a template. It's like imagine like a VM template. Then I define the base where my application is going to run. Now I'm defining another one to build my application. What I need to build .NET, I need the SDK. Then I start from the SDK. I get my work directory. I copy my project there. And every time I'm doing something here, you can see there is a new layer being created, and that's how Docker works. For some of those commands, they create a new layer, because Linux is nothing more than like mixing file system layers. That's how Linux works. And Windows, by the way, is doing the same since 2016. Since Windows Server 2016, they had to change Windows to be able to put like registry there, a lot of things from Windows, and they can do the same. And that's exactly in blue on the left, you now build your application, and you have your application inside this build. Then I'm going to publish. Then I'm going to create another one from the build where my build is. I'm going to run .NET publish. And from that .NET publish, I'm going to copy this to the final image in green. See, with four different statements. And all these things there, they run when you, and that's my final image at the right, okay? That started from the base image, copy everything from .NET publish, and create this green image, and that's the image that I'm going to deploy. All this process is happening with one command called docker build, and now you have even commands to build the image that you can build for all the platforms, for ARM, for Linux, and in a single command. Okay, and that's how building your application works. Without that, you don't do anything. You need this Dockerfile. You need to do that, and the final image will be that's the one that you're going to deploy. I'm going to skip a little bit, but I'm going to share these slides, and you can see how that works. For developers, they love, and why I put this slide here? Because GRPC now is the main thing. And the kubelet use GRPC to talk with containerd and all the magic happening on Kubernetes. There is the network, they talk with, they get the image that's going to be deployed, and the image is exactly what we just built on the previous slide. And Kubernetes go even deeper. You can have multiple Kubernetes core containers or as pods, and they manage everything that for us, okay? And we as a developer, we're going to use some of those products here for your local development. You can have Docker Desktop, Rancher Desktop, some things called Kind, I just saw you publish a video last night. Yeah, Marcel there, he published a nice video about Kind and about code space. You can run most of those things inside, GitHub code space now. And just look his channel there, the DevOps guy, the DevOps guy, YouTube channel. If you're not following, he should be following. And that's exactly what code space is for. I have been using Kind on code space for a while. I have code space there using Kind, and you have Docker installed inside code space. Just get the CLI, you can have Kind, you can have clusters inside code space. You can simulate, create all your clusters, all your people do inside the agents, GitHub agents, you run exactly testing. And you create a whole cluster, you deploy application, you run tests, and you kill everything, destroy everything. Inside your pipeline, you can do that, inside your testing pipeline. And in your local development, you can do the same. And what I have here, let's go back, see if my range is back or not. Yeah, I have a Rancher desktop installed. You download, Rancher desktop.io, install, that's the current version. You can integrate with your WSL, Windows Subsystem for Linux, version 2. Install the Windows terminal, if I'm using Windows. Rancher desktop and Docker desktop have for Linux as well, and for Mac. Should be fine there. I should have Docker running here. Yep, I have. See if I do a Docker PS. I have a lot of things running there. And I have my cluster as well. And then I want to see everything that's on my cluster. And that's an AKS cluster that I created. Let's try to get, because I had to close everything. Restore. I love restore. See, I just created an AKS cluster a little bit before. If you never saw AKS cluster, I created a cluster for development. You still have credit, that's good. And you can see on node pools that there's just one instance there. Nodes, but the outscaling is ready, means that you can scale to 3 nodes if there are workloads to run, scale up and down. And you have a full dashboard for you as a developer to look your workloads. Let's say I run that application called NDC Melbourne API. That's my application running. I can go on service. Remember that service is a load balancer. I can just click here and I can see my application. That application, I think, is that's a new minimal API template from Visual Studio Code 2022. And I'm going to show that one as well here. And what I had to do, I'm going to open Visual Studio there. Right there. Okay. See, that's my application. Better now? The Dockerfile I was talking about is this one. Looks similar, exactly the same. It's exactly the same. But now we have a command called, open that. Ooh. The other way. That's the Azure CLI. Okay, there is AKS, Azure Select AKS. You have a new extension called draft. And if you look draft, there's an option called create. And look what you can do. You can now, draft is an open source project as well. You can see on GitHub Azure Draft. That's the version 2 of draft. What draft does is they can, let's go a little bit up. They can do those commands there. They can create your Dockerfile, means that I don't know how to write a Dockerfile, draft can do it. Okay, Visual Studio, the full Visual Studio can do it as well. Draft can do it. But draft is there for a while. Now I have a new version that we rebuilt from scratch where you can not just create your Dockerfile, you can create your Helm, or if you're using other solutions like Kustomize, or even just using the standard Kubernetes YAML file. That's how Kubernetes deploy things. But I'm trying to avoid you to understand how all these things works. Okay, the first thing you have to understand as a developer, you have to deploy application using code generation. Then you try to go there and look how that works. Otherwise, you're never going to start. And that's what blocking many people to use Kubernetes, is they don't know how to deploy the application. Okay, then use the tools, deploy application, then you go there on everything that was created and you try to understand. Okay, if you have to. And that's what draft does. Draft can, you can run draft create, you can create, that's exactly what I did for this project. I run draft create, I create the Dockerfile with the Helm. And if you go back on the code, there's a folder called charts, and there are templates here. And that chart is how Helm works to deploy application. It's nothing more than a bunch of templates to build the Kubernetes manifest YAML file for you. You just pass like parameters. We're using Bicep here or ARM. Everybody uses Bicep or ARM automation. It's the same thing. Yeah, you have to pass parameters for Bicep, for ARM, and then you'll be replaced, and you're going to build your final manifest to be applied. For Azure, that's how Kubernetes works. Azure, we talk with API as well. Kubernetes, we also talk with API. And I mean, it means like, if you like Bicep, there's nothing wrong with, Kubernetes YAML file Helm. It's the same kind of abstraction, and you just have to give a go there. But you need that. Then you need a Dockerfile, you need the chart, and you need a pipeline. If you're not using GitOps, you need like you need a GitHub Actions. And Draft can do the whole thing for you. That's a GitHub Action. And you can see that generate workflow, that's the workflow for GitHub Actions. You can set up as well authentication. And the app command is just doing the GitHub workflow and authentication for you. Means that that's exactly what I did. And if I go back from my repository, you're going to deploy again. No, it's not deploy again. I had to remove the probes because and that's what the pipeline that was built. What they do, they build the image. And look the nice thing. They're creating a workflow for us, integrated with Azure Container Registry. They get that Docker file that we saw on the slide step by step. They don't run Docker build locally anymore. They send to Azure Container Registry. The build is done there. It's called, task inside the Azure Container Registry. And they create all this pipeline for us. They connect on Azure. They build an image. They create a secret just to tell the cluster how to connect with Azure Container Registry to get your image. Your image is like your application. It's like your zip file application. That's your image. That's what I call image. That's why application deployment release are. Okay, it's like an artifact. And that's inside the Azure Container Registry. and then they deploy. Connect with Kubernetes, get that Helm chart there, generate the manifest, like what they need to send to Kubernetes, and deploy application. But the nice thing now is it's all done for us until we, go away and understand a little bit deeper how that works. Because we lost, time at the beginning, we don't have more, time left. I'm happy to, on the next session, go a little bit deeper on the demos, because I end up doing a lot of, on the container side as well. But I think still have some minutes for questions, and I hope we could make up here for the beginning. And why I move a simplify AKS? Because that's what the developer should be focused. Don't start for the infrastructure. Just go there on the Azure portal, create a cluster as a developer. Okay, get one single node, run Docker AKS draft from the command line, create a Dockerfile, create your shard, create your GitHub actions, and deploy. If that works, then you go there and try to understand exactly how that works later. But you have your application now up and running. Any questions? You could be asking anything about AKS, more deep. If you want to ask about features, there's a lot of things coming as well. Any feature from build you want to ask? Yeah, I'll tell you a couple of, I have a couple on the browser here open. One is the extensions. The same thing that you have on Azure Container Apps, DEPA, GitOps, using Flux, you can have on AKS. Node 1, there's a Flux v2 now, the latest version of Flux. Microsoft is working closely with RealWorks. And there's all documentation explaining how to use that on AKS. Scaling for Cader. If you want to scale your application based on like a queue, based on storage, based on database, anything that this project Cader, out scaling from CNCF. The same way that works on Azure Container Apps, you can run on AKS as well. Okay, it's an extension you don't have to manage. CSI drivers, I love that one because now you can do things like snapshot, clone a volume, resize disk, is in preview, but it was a challenge to do those things. Like some people want to run like a database and want to keep increasing the disk size as a volume. ARM is a big one. Imagine how much you can save money running as it was about, probably you can save a lot. The draft one. And another big one is web application routing. That used to be only for developers. It used to be called HTTP routing. Now it's called web application routing. I even get confused with the names. But if you go on the Azure portal, there is one thing called HTTP routing. That's the old one. Okay? Even there is a disclaimer there, say that's just for development. What that does, when you deploy application, you can put a notation there on your YAML file to say, I want like a DNS for that. I want a full qualified domain name for my application. You can connect with Azure DNS, and you can get that subdomain for your application, all automated. You want to say, that's my application name. They're going to get like a subdomain for your application deployed, and you have if your DNS using zones or anything, it's going to do it. Now this one is a production one. Means that we are supporting that becomes like what you call ingress controllers on Kubernetes, but now that's production ready. Okay, and means that you maybe don't have to care more about ingress controllers and are you using Nginx and which one are you using there? Nginx. Yeah, we're using as well, but we are simplified that, and many customers ask for that. I don't want to manage the ingress controller. I want to have this as a solution, And that will be integrated with the service mesh, they call open service mesh, that's also CNCF, where you can automate secure communication between your microservice without you have to care as a developer on that. It's all done by the cluster, by this mesh. And this thing works with open service mesh out of the box. I think if there's one feature you should look, and if you haven't used ingress controllers or Kubernetes or containers, this is one. Because that's going to simplify a lot. You see DNS zones, OSM, CSI driver, Nginx ingress controller. Means that we are doing the job for you now. And if you look all across AKS, there are, so many features that from build, and the AKS team is growing. Is one of the most productive teams that I know at Microsoft. Is like unbelievable. And my job is to work with those teams as a cloud developer advocate, get your feedback, and try to improve the product. And the thing I want more now is the developer experience. We have a lot of things that we're doing, things that I haven't talked here because we are working on that, like bridge to Kubernetes, and you can ask me that later, but we are working, like draft is the first thing, but just the beginning. It's just the beginning. Okay? We're trying to automate the whole process from infrastructure to application deployment, GitHub Actions. If you don't want to use GitOps, then we get all the developer experience now. And then if you have ideas, if you want to propose something, if you are doing something different that we should be looking, let us know. That's the time. That's the perfect time to improve developer experience. And the whole AKS team is looking on is in charge now of those projects. Then if our customer already work with the AKS team, Marcel, I know that you're talking to them, just give the feedback because the AKS team now is working directly on that. I'm taking your break time, but if you want me to keep talking, I can keep talking. Nobody left. Yeah, I'm going to share my slide, and if you come back on the 140, I can go a little bit deeper on the local developer experience, on the container apps, and how you move from container apps to AKS. You should be starting with Azure Container Apps. Once you need more, you can move to Azure Kubernetes Services. And that's the journey from containers. As a final answer that I normally answer is, what's the difference between app service and like Azure Container Apps and AKS? For me, is on the scaling side. If you want to 6 instances of my application running, on Azure App Service, you need 6 different nodes, what you call web service instance, and you pay for all the 6 ones. If you have like a tiny Go microservice that 20 megabytes, and you want to run 5 copies on web service, you need to pay for 6 instances. Even if it's like 20 megabytes running here, 20 here, 20 here, if you want to spread. There's no way to run 2 here, and 2 here, and 2 here. No. On Azure Container Apps, on AKS, you can run all 6 in one node. That's why your developer node is just one. And you can have 5 containers. There's no way to do that on App Service. Okay, and only that reason, if you need scaling, is a reason to move to AKS or Azure Container Apps. George, my application is just like 1 instance, or maximum 2, and my app service is always with 2 instances. That's fine. Leave there. Don't touch. But if you're moving to microservice with many instances, you have to look because of that. Otherwise, you're going to get a big bill, going to blame us. And I have worked with many customers complaining about that. Explain just using the wrong product for your solution that you have. If you need that scaling, you can use Azure Container Instance, you can use Azure Functions, or you can use any container. Even in Spring Cloud, you can use OpenShift, AKS, Azure Container Apps. There are a few options. But you have to understand that. Otherwise, you're going to get this big bill. If you're using app service environment, it will be even bigger because of that. But there's nothing wrong with using app service. If you're using app service, go for V3, premium V3, and sign for at least 1 year. You'll be safe. You'll be paying less. And if you're not using app service V3, move now. Okay, even before you move to AKS, move to app service premium V3. You pay less, you'll be faster, you need less CPU and memory for your application. And I think that's the first thing. And you can play there with containers, and when you're happy, move to another one. But thank you. I think we have another session soon, and thanks for coming. Appreciate it.